All right, section 6.2. Now we're going to actually use the normal distribution. So we already said that in order to go from a normal distribution to a standard normal distribution, we need to use this formula right here, x minus mu divided by sigma, which your x values, all of these numbers right here in a normal distribution, all of these are your x values. Once you put each number through this z-score, now all of these numbers are not x values anymore. Now they're z-scores. So for example, say we took 1050. So I'm going to take z 1050 minus, okay, my mean is 1010, divided by my z-score. Okay, so the difference between this number and this number is 20. Okay, so I've got 1050 minus 1010. That's going to be 40 over 20. Knock out those zeros. I really just have 4 over 2, which is 2. Okay, so I'm looking at this value right here, which is 2 standard deviations away from the mean, or same thing as a positive 2 z-score. Okay, so first question. A pediatrician obtains the heights of her 203-year-old female patients. The heights are approximately normally distributed. I have a mean of 38.72 inches and a standard deviation of 3.7 inches. Determine the probability of a 3-year-old female that has a height less than 35 inches. Alright, so first thing, I need to put the mean right in the middle. So 38.72. And then usually I write to the side, okay, my standard deviation is 3.17, just so I can see it. Okay, now we are looking for 35. We'll say 35 is about here. And I'm looking for less than that number. So I'm looking for the area to the left. Now since my mean is not 0 and my standard deviation is not 1, my x values are not the same thing as my z-scores. So I have to put my x value through this z-score formula, which that is 35 minus 38.72 divided by 3.17, which you'll get a negative 1.17. Now when you're trying to find the z-score, you're always going to go to 2 decimal places. The reason is when you go back to the z-score table, notice all your z-scores are in 2 decimal places. 2 decimal places here, here, here. You're actually looking at these right here. All of these are in 2 decimal places. So that's why we need to round back to 2 decimal places as well. And also, it's a negative number because, okay, here's your mean. We were below the mean, so all of our z-scores over here are going to be negative. All the z-scores over here will be positive. Okay, so I'm going to use that negative 1.17, and I'm going to go back to my z-score table. I need to be in the negative side. Alright, so negative 1.1 right there. And then I need 7. So 0, 1, 2, 3, 4, 5. There's 7. Okay, where they intersect, that's going to be my number. Oops, right there. So 0.1210. Okay, so that's the area to the left of the z-score, which in this case, this is what we're looking for. We want the area to the left of our z-score. So right here, that's an x value of 35. We changed it to a z-score of negative 1.17. The area to the left of that z-score is 0.1210. So the probability that you've got a 3-year-old female patient that is less than 35 inches, that's going to be 0.1210. And that's your final answer. Okay, part B. Find the probability that a randomly selected 3-year-old girl is between 35 and 40 inches tall. Okay, so same thing. We are going to put our mean in the middle. So we got 38.72. Now I'm looking between two values here. I've got 35, which we'll put right there, and 40, which we'll put right here. So right now, both of these are an x value. We need to change both of them to a z-score. And we already did this one. This was negative 1.17. I need to do the same thing for this one. So 40 minus 38.72 divided by 3.17. And all that information is coming back from here. I had a mean, had a mean of 38.72, standard deviation of 3.17. So we're still working with this problem right here. It's just a different question. Okay, so our z-score, since it's above the mean for the 40, since we got a mean right here and our value that we're looking at is 40, which is above the mean, we're going to get a positive z-score. So the z-score that you would get for that one would be 0.40. Okay. So all of this right here, we already found that the area for this first, we'll call it Z2 and area 2. We'll call this Z1, Z1. We said it had an area of 0.1210. Now what I'm looking for is the area to the left of my z-score of 0.40, or sorry, 0.40, which is going to include all of this, okay, to the very end. So from that z-score all the way over, okay. So starting here, all the way over, that's to the left. To get that area, I need to go back to my z-table and go to the positive side. Now I'm looking for 0.4. There's 0.4 right there. And I don't have 0.41 or anything. I just have 0.4, so I'm looking at 0. So my answer is going to be 0.6554. So for the area to the left of that z-score is 0.6554. Can we go back? Alright, so this is 0.6554, or area 1 0.6554. Now remember back in section 6.1, if it was between two numbers, and all we're looking for is the middle, so between these two, I just need this right here. We're going to subtract those two areas. You always start with the bigger one. So A1 minus A2, or 0.6554 minus 0.1210. That's going to give me the area between these two numbers, which is 0.5344. So the probability that a 3-year-old girl is between the heights of 40 and 35, so 35, oops, and 40 is equal to 0.5344. And that's your final answer right there. Okay, part C. Find the height of a 3-year-old girl at the 20th percentile. The 20th percentile is the same thing as the bottom 20%. Okay? So we are going to have a mean. That's still 38.72. And now we're looking for the bottom 20%. So we can just draw right here and say that, well, this is the bottom 25 or 20%. Which we'll change that to a decimal. So really, this little section right here has an area of 0.20. Now what we're trying to find is the height of a 3-year-old girl. It's really the same thing as saying find the x value for a 3-year-old girl at the 20th percentile. So I'm trying to find this x value right here. Before I can do that, I need to work with this problem right here. Notice I can find a z-score because they gave me an area. What I don't know is my x value. So if I move my standard deviation over to the other side, then I have x minus mu. If I add my mu to both sides, I get x is equal to mu plus z times sigma. This formula will be given to you on the formula sheet, so you don't have to memorize that. Now I've got my mean, that's 38.72. I've got my standard deviation. They said back here, that is a 3.17. The only thing I don't have is my z-score, but they gave me area. So I can go back to my z-score table, and now I'm looking in the middle here. I need to find 0.20. Now, first glance, I'm seeing 0.8, 0.8. So if we go to the negative side, okay, I'm seeing 0.1s. Okay, here's 0.2s. So it's going to be somewhere in here. Now, it may take you a little bit to find it. And there it is right there. This is the closest number I can get to 0.20. So this 0.2005, that's the closest number compared to 0.200 or 0.2033 and 0.1977. This number right here, that is the closest number to 0.20. Okay, so the z-score associated with that one is negative 0.84. Okay, so we've got, at this point right here, I have negative 0.84. So I have everything that I need to plug into this formula. I have x is equal to, okay, my mean is 38.72 plus a z-score of negative 0.84 times 3.17. Okay, so that should give us a value of 36. And since we're talking about height and they're measuring the height in inches, this is 36 inches. Okay, so in the 20th percentile, someone who's in the 20th percentile, the same thing as saying that they are 36 inches. Okay, so they are taller or as tall than 20% of all the 3-year-old females.